Hi, welcome back. So here's another video on BBC Basic Performance tips. We've got two comparisons today. Firstly, it's the comparison of the print tab versus VDU. So typically when you're printing out some text at a particular location on the screen, you would print tab and then you'd have the string. In this case, I've cheated a little bit because I'm only putting a single character. So this may only really be applicable if you're plotting a single character to the text screen at a particular position. Notice that if the string is bigger, that can have some other implications. But anyway, so it's the print tab versus VDU31. So this VDU31 command, the next two parameters are the X and Y, and then the next thing is a 65 is the ASCII character for A. So like before, we have this machine offset which gives a difference between PC mode and BBC mode. So if you're running it on a BBC, the Q factor is a lot less, otherwise you'd be waiting for a hell of a long time. So if we just run that, you can see there's a marked difference in performance between print tab and VDU. So I'm not sure what that's called. That should be time. Very strange. Anyway, you get the idea. So we can just quickly run that again and make sure it looks good. So there you go. If we then put that onto a BBC emulator and run it in BBC mode, I've sized that slightly longer. It's going to take slightly longer just to try and pull out the differences. So there is a difference. It's not huge, but there is a difference. So each time you're plotting something, let's say for example you were plotting, let's say you had a command where let's go to the end here. So you had something like X, Y, and you were plotting maybe if you had the ASCII value of a character 65, that would print A, and you had that in an array or something like that. Or if it was extracting a value from a string literal, so that for example, then the basic interpreter has to deal with all that stuff, has to convert it all, and there's obviously an overhead in that. So here it's plotting it directly. There is a difference, there is a performance gain. It's very, very small, but it still exists. So that's the first test. Plotting a single character, X, Y, you can use VDU31, and then you follow it on with anything else you want. So if you wanted to do that, for example, that in theory, if I've got it right, should print ABC. Okay, so obviously if you don't have to encode the string as a string literal like this, and you know what the ASCII values are up front, then you can get this performance benefit, and it can increase over time depending on how much you've got to do, because it's not having to maintain a pointer to the string and then index that through the string and whatever. So you get a performance benefit there. The other thing I want to look at is this one here, which is a comparison of using the SPC function versus a string literal. Now this is a bit of a weird one. I don't think I've ever really used SPC, but the SPC command is you specify a number of spaces to return back. So what we've got here, let's just move that out of the way, is a test which will test a string literal where you've got a bunch of spaces in the middle versus more spaces, versus having the string literal but with space inside it, a large number of spaces inside it. So these are equivalent, but obviously you can see they look different, versus just the spaces themselves. Okay, so there are some interesting results. If I run that, you can see here that there really is there are some differences, but it can be a little bit sort of haphazard in the kind of results you get. What is consistent, he says that consistent, it was consistent, now it's no longer consistent. Okay, so I think the conclusion from that, if we just break it down, so we got the string times short. So this is a short string, short bunch of spaces inside a shorter string, versus the space function in the short string. That is quicker. However, if you go longer, that is actually slower. That's what I'm saying. It looks a little bit weird, a little bit inconsistent. If I run this again, then it's slightly different again, which is a bit weird. So we can see here that the amount of time it takes for the short string and then the short string there, so that does seem to be quicker. However, if you look at the longer string, the string literal, i.e. this one here, seems to be quicker than this one here. So it's a bit strange. If we then look at just the position, so we're tabbing those characters, and you've just got one continuous space, so you haven't got this breakup here of the string. It's a string literal is just spaces. Then it actually seems to get worse, and it's consistently worse, which is a surprise. Actually, it's the same there. This thing is very random. I think what we'll do actually is let's increase the number of iterations for the PC one, because maybe we're just on the ragged edge of it and we haven't got enough resolution to actually look down and see the issue, see the differences, mark the differences. That's probably what it is. If your Q value is on the edge, then you're not giving it enough time to pull out the performance. The runtime is always going to vary a little bit in performance. On the PC especially, you've got a lot more power, but you've got a lot of back-end processes, so you probably need maybe even an even longer Q value, given that it's not actually doing much processing. Let's just whack it right up and see if we can get a more consistent result. It's taking a lot longer, but that's good. That's a good thing. Hopefully we can see the resolution. Okay, so we can see here, let's compare the string short, the string literal short versus the space function short. Space function short is more, space function long, well, fractionally better, but essentially that's pretty much the same. And the same is true with the string, a string of blank characters versus this space blank characters. I must admit, I'm slightly surprised and a little disappointed, but with these tests, it's more about finding what those differences are. You have an idea and think, oh, I wonder if this approach will be better versus this approach. And really, even though it would appear on the face of it that Space Command is, I love that name, Space Command, was going to do good things, and in some ways it's good because it is a bit more condensed in terms of code. For example, if you wanted to blank out a line of 20 characters, for example, then setting the position with a tab or even a VD31, who knows. You could either have a string literal of 20 characters, fine, or you could have an SPC bracket 20. That's actually quite nice. It means that not only can you inject a variable to change the amount it does, which is a useful feature. Without that, you'd have to do a string concatenation, which would take more time and use more memory. So you can reduce the amount of space your program takes up. That's a good thing. Equally, if the performance is there or thereabouts, is more or less the same, then maybe the advantage of having that reduced program space is good. The rub is it's not as easy to see. You know, if you've got a space string literal, you know, it's very easy to see what it's doing. Where SPC, you'd have to, you know, it's not that difficult, but it's not quite as obvious. So we've just run that again. We can see here that in theory, the space-time blank here is actually greater in theory. So yeah, so that's this bit here. So 20 spaces versus 20 spaces. That's saying that it took less time. Possibly. We'll run it one more time and then we'll put it in the emulator and see whether the BBC Micro itself thinks differently about that. Now it's actually taking more time. Okay, so let's draw a line under that and stick it on a BBC Micro with fewer back-end processes running. Basically none. I'm not sure I've got the Q value set correctly, but we'll soon see. So on BBC it's set to 1000. That would have paused execution, so maybe I should run that again. Yeah, I'm going to do that again. That wasn't very fair. Hang on a sec. Let me just try that again. Run it again and then leave it alone. It wasn't too slow. So that's the first test. So that's a string literal with a fewer number of spaces, string literal with a lot of spaces. That's the string literal with the space command, string literal with the space command and more spaces. Then the next two are invisible. Those tests is setting the location on the next line, which is line row 8, I think. Yeah, of 20 spaces, so you won't be able to see that. And then 20 spaces using the SPC command. Okay, so according to this, we'll compare this one first. So that's the string literal, the short string literal versus the space command string literal. String literal long versus the long space command. I'm not surprised about those because obviously this is doing more work. You've got essentially two string literals and you've got a command in the middle of it, so it's what you'd expect. It's just interesting to see what might be the case if you were, for example, creating a box on the screen or something like that where you wanted a consistent number of spaces. In some ways it's easier to do that using the SPC command than have string literal, especially if you wanted to vary it, because then you could inject a variable in to change that. That's fine. However, where it does potentially have benefits is this bit down here. So we're saying we're going to blank out this line at column 0, row 9. We're going to use 20 spaces. Go, off you go. So really these are equivalent. It's doing the same thing, and at this point you've got a string literal taking up 20 bytes, whereas here you've got a token and you've got a value which I think would be 4 bytes. So you might be 6-7 bytes worth, so it's taking up less space in programming code, and you have the advantage of being able to put data in there. You might even be able to inject a variable, integer variable, which may even be quicker than having a literal variable value. So we run that and that's all fine. So let's run that again. So we had a definite advantage in terms of performance, but it's always good to run it again. I think it's perhaps a more valid space to run it in, because you don't have any background processes or far fewer. Should be more consistent. Now the speed of these does vary a bit, and it would be best to put it on a real machine, but I think for the purposes of this test that's probably good enough. I'm going to predict it's going to be roughly the same, in which case there would be a slight advantage, and I would say the use case would be if you wanted to blank out a line of text or characters or whatever, then it might be useful to use the SPC command to do that. So again, it is consistent. So 661 for the string literal blank, 20 spaces, versus the space command. Yeah, okay, so there is an advantage. It's small, but I think as we're discovering with these tips and tricks, there's no sort of turbocharged command that's going to make everything quicker. It's by degrees, so there might be a little improvement here, a little improvement there, and over the course of time perhaps these will add up to being something better. Obviously for this, as I mentioned, the use case is perhaps a little bit more narrow than I originally thought, but you never know. It could also be that you could use this to blank a whole area of the screen off, just using the SPC command. That's interesting. I might try that to see where there's a difference between having multiple lines blanked out. So if you've got a 40 character width screen, then if you wanted 10 lines, you have 400 in there, and it would push 400 spaces into it, and that might be interesting versus doing either a single string literal and moving the cursor position, or having a string literal of 400 characters. I'm not sure what it would think about that, or having 40 characters and doing it line by line. So I don't know, there could be advantages, edge case perhaps, but interesting stuff. Thanks a lot.